we're going to have 4 items that we're going to try to hash into this giant Cuckoo hash table. And the Cuckoo hash table has 2 subtables, T1 and T2. And so each one of those 2 subtables has 2 slots, corresponding to H1 equals 0, H1 equals 1, H2 equals 0, H2 equals 1. Now, we have 4 items that we are going to try to hash into this big Cuckoo hash table. And so I've already computed their hash functions. So item A, for instance, its H sub 1 of its particular key is 1, and H sub 2 is equal to 1, and so on. So you can see all these hash functions here. So let's do round 1. What do we do on round 1? What we try to do is place all of the alive items, and we start off with all the items being alive, and we're trying to place them all into T1 using this hash function. So now we see that items A and C both would like to map into this bucket, and items B and D, because of their values of H1, would like to map into this bucket. Now, we can only fit 1 item per bucket, so we're going to arbitrarily pick a couple of items to win. Okay, so I'll arbitrarily pick that C and D happen to win here. D is written into hash bucket number 0, and C is written into hash bucket number 1. Cool. And so A and B are still alive. And now we'll move to the next iteration of the algorithm, and we'll use H sub 2 to try to map A and B into table 2. And we see, well, both of these guys would like to map into this same bucket. So again, they're both going to try. Only one of them is going to succeed. For the purposes of argument, I'm going to say that's going to be B. Okay, so now we still have element A left after both rounds. So here's the neat part. We now go back to table 1. And we know that if we hash item A, it's going to collide with an item already stored in the hash table. We know that because it didn't succeed the first time. So we're going to try to hash it again. But now, when it collides with an item that's already in the hash table, here's the different part. We're going to take A and place it into the hash table, and we're going to kick out the item that's already there and continue. And now we continue on the next iteration of the algorithm again. We see that the only item that's left alive is now C. We see that its value of H2 is 0. So we can safely place C into the hash table here, and we're done. So the big picture here is that by kicking out things that are already in the hash table, we have a new set of items to try to continue to place in the hash table, and maybe they'll fit better than the old set. And we continue to apply this procedure. On each iteration, we always try to place our outstanding items into the next subtable of the hash table. And if they succeed, they kick out the items already there until we have no more items left. Now, will this always succeed? Yes or no?